Hello everyone, welcome back to my YouTube channel. In this video, I want to explain how to solve a question from Past Paper EJU Mathematics 2020, Course 2, question number 1 from the first section. By the way, I got this paper from one of my subscribers, so thank you for you who sent this past paper to me. But we do not know this past paper comes from which session. So if you guys know this past paper come from which session, you can let me know by typing it on the comment box below. If you want to watch the solution from the other number on this paper, you can check link on the description box below, and you can also check my EJU playlist if you want to watch the solution from the other past paper. Before I start, if you like this video, don't forget to hit the like button, share this video, and don't forget to subscribe my YouTube channel. Okay? In this question, we have a quadratic function y equals to 1 over 4x squared, and then let a be a positive constant. So you guys need to remember that a is a positive constant. And then when we move the graph or this quadratic function by parallel translation, the resulting parabola and the x-axis intersect at negative 2a, 0 and 4a, 0. Let us consider the equation y equals to f of x of this parabola. So this is my first quadratic function, or this is my initial parabola. I will translate this parabola, and then the resulting parabola and the x-axis will intersect at negative 2a, 0 and 4a, 0. The new parabola, let us denote it by y equals to f of x. The first question is, the function f of x can be expressed as blah blah blah. So after I translate this initial parabola, the resulting parabola can be expressed as blah blah blah. As you can see here, my parabola or my quadratic equation intersect the x-axis at negative 2a, 0 and 4a, 0. From this information, I already know that my new parabola, if I write down in its factorization form, the result should be something like this. Y equals to 1 over 4 x minus x1 x minus x2, where x1 and x2 is the x-intercept. You can see here, if I want to find the x-intercept, I can equate this equation to 0, and then I will obtain x equals to x1 and x equals to x2. This is my x-intercept, which is negative 2a and 4a. So my new parabola has an equation 1 over 4 x minus negative 2a. So I got plus 2a and x minus 4a. This is my new parabola. So AB here is 1 and 4, C is 4, and D is equals to 2. I already obtained A, B, C, and D. This is my first answer. And then the range of values of x such that the value of y equals to f of x. You need to remember, this is our y equals to f of x, is less than or equals to 10a squared can be obtained by solving the inequality blah blah blah, and it is blah blah blah. So now I want to find the range of value of x such that this equation is less than or equals to 10a squared. So if wait a minute, yeah, I will move the equation here. Then for the answer for number 2, my f of x must be less than or equals to 10a squared. I need to solve this inequality. Before we can solve it, I think we need to simplify it first. If I multiply 1 over 4 to the other side, I will obtain 40a squared on the right hand side. And then for the left hand side, I think I will expand it. So if I expand the bracket here, I will obtain x squared minus 4ax plus 2ax minus 8a squared less than or equals to 40a squared. And then if I move 40 to the left hand side, I will obtain x squared minus 2ax and then negative 8a squared minus 40a squared. I will obtain negative 48a squared less than or equals to 0. So this is my inequality. That means E is equals to 2 and then F and G is equals to 4 and 8. I already get E, which is 2, and then F and G is 48. And then if I solve this inequality, I will obtain the range of value of x. So I expect after solving that inequality, I will obtain letter H and I. If I want to solve this inequality, I can solve it by factorization the quadratic equation first. So I will vectorize it. If you see from this equation, of course we can vectorize it into x minus 8a x plus 6a less than or equals to 0. Then my critical value is 8a and negative 6a. This is my critical value. 8a and negative 6a. That is my critical value. And then if I draw a number line, and then I will put the critical value in this number line. Don't forget a is a positive constant. That means negative 6a should be on the left and then 8a should be on the right. Negative 6a and 8a here. If you check the sign, if I substitute 0, 0 should be somewhere here because a is positive, yeah? So this is a negative number and 8a is a positive number. So 0 should be somewhere here. If I substitute 0 to my equation, the sign is negative. So the sign here is negative. That means on the left and right is positive, and then I will take the negative region. Since my quadratic inequality less than or equals to 0. So this is my solution. From this number line, as you can see, my solution is negative 6a less than or equals to x less than or equals to 8a. That means h is 6 and then I is 8. 6 here and 8 there. And then the final or the last question for number 1, suppose that the length of the segment between the intersection of the straight line y equals to 10a and the graph is 10. So if I give you an illustration, I have an open concave parabola. Since the coefficient of x squared is positive, yeah. Since the coefficient of x squared is positive, so I have an open upward or concave upward parabola. My parabola will intersect with line y equals to tan A. So just assume this is my parabola. And then this parabola will intersect with the line y equals to tan A. This is the line y equals to tan A at two different points. And then the distance between these 2 points is equals to tan. So if I want to find the equation that can relate tan with this illustration, that means I need to find the x coordinate of the intersection point between my parabola and the line y equals to tan A. I need to find these 2 coordinates. I will assume this is x1 and then this is x2. After finding x1 and x2, I know that x1 or the absolute of x1 plus x2 must be equals to tan. So my first step here is I need to find the x coordinate of the intersection between my parabola and y equals to tan A. If I want to find the intersection between our graph and y equals to tan A, we can just equate them. The equation of parabola is this one. This one, wait a minute. This equation or this expression must equals to tan A. And then we need to solve this quadratic equation. I will multiply 1 over 4 to the other side, and then for the left hand side I will expand it. We already got the expansion here, yeah. The expansion is this one. So this one is equals to 40A. Is equals to 40A. And then if I move 40A to the other side, I will obtain x squared minus 2ax minus 8a squared minus 40a equals to 0. To find x1 and x2, we can use quadratic formula. I think I cannot factorize this expression because the last term contain a square and a. So I think it is difficult for us to vectorize this expression. So if I want to find the x1 and x2, I can use quadratic formula. Negative b, this is your b. Negative minus 2a, that means 2a plus minus square root b squared negative 2a squared, you got 4a squared, minus 4 times a, coefficient of x squared is a, your a is equals to 1, times c. This is your c. Include the negative sign, yeah. Negative 8a squared minus 40a over 2a. 2 times 1. If you simplify this expression, you will obtain 2a plus minus square root 4a squared minus 4 times negative 8a squared. You will obtain 32a squared. 32a squared plus 4a squared, you will obtain 36a squared. 36a squared, and then negative 4 times negative 40a, you will obtain plus 160a over 2. You can factorize, I think we can factorize 4 from this expression. If I factorize 4, then I will get 2a plus minus square root 4 9a squared plus 40a over 2a. You can move this 4, square root of 4 is equals to 2, yeah? So I can move 4 here, becomes 2 there, and then I can cancel out 2. So my final answer is a plus minus square root 9a squared plus 40a over a. I got two answers here. The first one is a plus blah 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 over a, and then the second one is a minus blah 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 over a. That is your x1 and x2. If I use my illustration, then x1 is the one that is negative. So I can assume that x1 is equals to a minus square root. Wait a second, I think I override a here, yeah? There is no a here, that's only 2. So sorry for my careless mistake. So I think this is my x1 and x2. There is no a on the denominator, just like this. So my x1 is a minus square root 9a squared plus 40a, and then my x2 is a plus square root 9a squared plus 40a. That is my x1 and x2. And then since the distance between x1 and x2 is equals to 10, that means x2 minus x1 must be equals to 10. You can imagine, yeah, let's say x2 is 8 and then x1 is negative 2. So 8 minus negative 2 is equals to 10. So to find the distance, I can subtract x2 by x1. So 10 is equals to, the distance is equals to 10, x2 minus x1. 10 is equals to, you can see this is x2 and then minus with bracket x1. So this one minus x1. Of course, you can cancel out a. Don't forget to put bracket here. You can cancel out this a, and then minus times negative becomes positive. Since these two is the same expression, then 10 is equals to 2 square root 9a squared plus 40a. I think this is our J, K, L, and M. As you can see, 10 equals to 2 square root 9a squared plus 40a. So J is equals to 2, K is equals to 9, and then L and M is 40. And then we see that the value of A is blah blah blah. By solving this equation, you will obtain the value of A. To solve this equation, I will divide 2 to the left hand side first. So I have 5 equals to square root 9a squared plus 40a, and then you can square both sides to get rid the square root. 5 squared becomes 25 equals to 9a squared plus 40a. You got a quadratic equation here. If you solve this quadratic equation by using, I think you can factorize it. If you factorize it, you will get, let me think, 925, 9 and 5. Okay. If you factorize it, you will get 9a minus 5, and then a plus 5 is equals to 0. Then a is equals to 5 over 9, or a equals to negative 5. Since a is a positive number, that is the very first information that we obtain from this question. A is a positive constant. That means my final answer is this one. We need to reject the second one. So a is equals to 5 over 9. That is the answer for letter N and letter O. And that's it. This is the solution for the first number. If you want to try to solve the second question from this past paper, this is the question. A little bit blurry, but if you change your resolution to HD, I think you can see the question more clearly. This is the question number 2. You can try to solve it by yourself, and then you can check whether your answer is correct or incorrect by watching my next video. This is question number 2. Okay, I think that's it for my video. Thank you for watching this video till the end, and I hope you can understand my explanation, and see you guys on my next video. Thank you and bye-bye.